We have all the basic UI elements for gameplay, so today we'll tie it all together by building the state control modules. These include the start game controls and operational latch from sheet 3, and the player up/ball and play counter and serve logic on sheet 1. We went deep into these sections when breadboarding, so we're not going to repeat that here. See part 10 for lots more detail. We'll start with the, start game controls, so I'll make a new file for that. For inputs, we'll need the start 1 and start 2 player game signals from those two push buttons. The 1 or 2 credit line, which should be called the 1 or more credits line. The 2 credit line, which is really 2 or more credits. 32 Victor, 64 Victor, 128 Victor, end game level, and Q. She then puts out 1 credit start, 2 credit start, the 2 player game indicator, start game, and attract. All other I/O in this section can be derived from these signals. We'll need those 2 start buttons, so let's go wire up a couple level shifting buffers for those. We'll need the serve button later, so might as well do all 3 right now. I'm using this compact control card, but the final circuit board for this will have the standard 44-pin card edge connector. We also need to add those 2 new ports to the PCF file. And suck those into main. We'll add the serve button stuff later. We've got everything we need for this circuit, so let's just wire it up. I'll do the top start 1 player game latch first. I made the decision early on to only provide the positive outputs for these latches, and here we're mostly using the inverted outputs, so we'll need some extra work. We'll need a loose wire for the positive output, then assign the inverted value. Add the credit hold latch. Add the bottom start 2 player game latch. Same extra work. Add the 1 or 2 player SR latch. Assign the start game output. And finally, wire up the attract latch. The positive attract line is on the negative output, so we need to do that extra work again. A little documentation always helps. I'll need a comma there. Forgot that paren. Copy that signature to main. Create the output wires. And connect it up. We don't have the credit lines yet, so I'll say there's at least 2 credits by dropping both of those. We don't have EGL or Q yet, so I'll tie down Q and wire EGL to debug button 1. Wrong names on those. And that's inverted. We now have a tracked, so we can get rid of that temp wire. The paddle module now takes in the real attract signal. And we can now use attract in the bricks instance. We now have start game, but we still don't have serve wait. I'll just turn that off for now. Oh, to test this, Q must be on. Press start 1 player game, machine comes out of attract mode. Press button 1 to simulate EGL and the machine returns to attract mode. Start a 2-player game. Same behavior. Let's quickly remove the credits. The start game buttons do nothing. Add just 1 credit. Start 2-player game does nothing, but start 1 works. Looks like the start controls are working nominally. Q comes from the operational latch, so let's go there next. This is exactly the same circuit found on legacy boards, and we added manual set reset buttons on the retro. We went deep into the details on how this latch works in part 10, so I won't redo that here. We call this the set point, where taking this down sets the latch. The first way we set the latch is when a coin is dropped. There are 2 feeds on the legacy and retro circuits, but only 1 here. We'll mix the 2 on the FPGA so we only use up 1 pin. The other way to turn on the latch is by pressing the set button. Here we have the reset point. This is dropped at the end of a game when there are no credits left. We can also manually reset it with the button. Another way the latch gets reset is when an electrostatic charge turns on Q2, disrupting the current flow to the basic Q3. You already noticed we're using a non-inverting buffer for set and an inverting buffer for reset. This was done purposefully for safety because Arduino GPI pins float up during power on and initialization. This does nothing for the set side, but forces the latch into the reset state at power on. On the output side, you'll notice we don't have a level shifting buffer. We ran out of LVC 244 gates, so instead of adding another chip, we just lightly pull up the run line to 3.3 volts, and when the latch is set, run is pulled to ground. There's no speed requirement here, so this is fine. The set and reset buttons do their thing, so back to the code. We need to add those ports to the PCF file and also to main. We can now hook the run line to the Q input of the start module. Put that second credit back. We're not driving the set or reset outputs yet, but we need to still assign values or the compiler will bitch that those signals have no drivers. We can do a couple of tests. The start buttons do nothing when the latch is off and work when we manually set the latch. Pressing reset properly places the machine back into attract mode. You know what? We can test those set and reset output drivers by hooking them up to our 2 debug buttons. Those buttons are active low, so I really need to change these names. Been bothering me for a while now. Much better. Hook those up. Button 1 should set the latch and button 2 should reset. I need to remove button 1 from EGL as well. Button 1 sets the latch and button 2 does nothing. That reset drive wire is hooked to the wrong place. Much better. Our set and reset drive lines are now working properly. EGL comes from the player up / ball and play counter, so let's go there next. I'll start a new file for that. We'll need 1 Henry, 2-player game, serve wait, H-sync, and start game. She then puts out player 2, the ball number bus, and EGL. We haven't talked about how we're going to handle configuration yet, but for now let's just add a balls per play configuration parameter and hardcode that in main. I want to make this wider so we can use that 4th bit as a balls forever marker. We've got all the parts we'll need, so let's just wire this up. Add that reset type latch. We'll need a loose wire for the output. Add the counter. The 2-player game port should be negative. Oh yeah, the start game port should also be negative. Even though we can make the ports positive or negative, I'm trying to keep them the same as the schematic name for each section's I/O. The upper 3 bits are the ball number and the lowest order bit is the player out. And finally generate EGL. Copy that signature to main. Create the output wires and connect it up. We now have the player 2 signal, and we can use that to generate the proper player 2 conditional line that's used by the paddle and flip screen modules. Well, we need a few configuration parameters. We'll make a configuration module later, but for now let's just add them here. Set that to 5 balls. For player 2 conditional, we'll need a model configuration parameter. We didn't put this stuff in the paddle module and just brought in P2 conditional. Now we can generate the proper value. That's not going to work. Should be 4 bits wide. We don't have serve wait yet. We can now hook EGL to the start game controls. We're not doing anything with the ball number output, so I'll run those into our debug hex display along with the player 2 indicator. We can hook button 1 to serve wait to test bumping this counter. And I need to pull those buttons off the set reset lines. Compile and upload. And she pukes. Once again, bitching about logic loops. The flattener gets a bit lost, but what I see is that EGL can reset the attract latch, which can reset the start switch latches, which can deassert start game, which can possibly affect the counter, and in turn EGL. You'll notice that this is just a warning, but we shouldn't ignore it. Wherever you see a capacitor on a digital line, they're usually adding a delay to prevent glitches. We can break this loop by delaying EGL by adding a D-type flip-flop triggered on the trailing edge clock. We do this on the trailing edge because almost everything in this whole system changes on clock's rising edge, so we want to stay away from that. This delays EGL by about 120 nanoseconds, removes the loop warning, and should have no effect on the rest of the circuit. I'll add a cheap D-type latch for the delay. That should work. Add clock to the port list and pipe that into the instance in main. I temporarily inverted H-sync to give us a better chance of injecting serve wait with a test button. Otherwise, this latch is nearly always held in reset. I think we should also add debug LEDs for EGL and a 2-player game indicator. Oh, that P2 conditional model check is wrong. Like I said, we'll work on a configuration model later, but we can do better than this by using some defines. Fix that. She now compiles fine, so let's test this section. I'll manually set the cue latch, then start a one-player game. The two-player game LED turns off. Press button 1 to simulate serve wait, and the ball in play number steps. A few more steps and EGL asserts when we hit 5. Remember that the ball number here is 0 based and is changed to 1 based for the on-screen display. To start a two-player game, the two-player game LED lights and the counter resets to 0. Simulate serve wait and it switches to player 2. Press again and moves on to the next ball for player 1. Step through all balls for both players and EGL asserts when we hit 5. That all looks good. Serve wait comes from the serve logic, so let's finish the last circuit for today. I'll add a new file for that. And we'll need the defines. For inputs, we'll need the signal from the serve push button, a tracked and start game from the start controls, the raw ball signal from the ball counters, H-sync, 8 Henry prime, and 4 horizontal UI lines, so we'll just bring in the bus. She then puts out serve wait, ball display, and serve ball detect. We already added the serve button level shifter hardware, so we just need to add the serve wait LED driver and hook that up. We'll need to add those to PCF and add the ports to main. We don't need any new parts, so let's wire this up. We'll do serve ball detect first, an easy one. Then the serve switch latch. Then the serve wait latch. And finally assign the ball display output. Now fix that. I've got an extra space there. Well, we need the GPIO port numbers. That's not magic. Compiler doesn't like pin 02. It'll change that. Copy that signature and drop into main. Add loose wires for the outputs and connect it up. Drive that LED from serve wait. Totally forgot about the latch output. We can now wire SBD, serve wait, and ball display to the ball motion instance. We can connect serve wait to the play counter instance. Also remove that temporary H-sync inversion. In the bricks instance, we can use the proper ball display, start game, and serve wait lines. And finally, we can hook ball display into the video sync section. Compile that. And she pukes. Great, another loop. Looks like the compiler does not like ball display being able to set the serve wait latch and affect ball display. Oh look, another telltale sign of a line delay. You do start to see a pattern here where the loop detector focuses hard on latch sets and resets. Let's throw another half clock delay on this set line and see how it goes. Add a cheap D-type flip-flop. Generate a delayed set line, and use that in the serve wait latch. Add clock to the module signature and wire clock to the instance. Compiles just fine. Hope it works. I'll manually set the operational latch and start a one-player game. The serve wait does not come on, and the ball just appears without pressing the serve button. Not too good. The LED one should be easy. Yep. Got the wrong port for that LED driver. Just a simple case of the dumbass. Wow, I completely forgot the set side of that serve switch latch. Kind of important. And we're using the inverted output of that latch. That's why the ball appeared without provocation. Try that out. Set the op latch and start a one-player game. The ball disappears properly and the serve wait LED comes on. Press serve. And the ball appears when it crosses into the near field. Miss the paddle. System transitions back to serve wait, and the play counter bumps to the next ball. A few more misses and back into attract mode. Start a two-player game. State properly switches between the two players with every ball miss. A few more misses and end of game. Nice. One thing we haven't tested in a while is flip screen, so let's turn that on now. Wow, I reversed those two model defines. And half my work is already done. Fix that. Start a two-player game. Screen flips when player 2 is up. Press serve and the ball is doing the right thing. Hey, great. Looks like everything's working properly. Today we successfully tackled the 4 sections making up the game state logic. Nice to finally be able to play an entire game cycle without jumpers and hacks. In the next video, we're back to UI elements with an on-screen display.